Adding and subtracting rational expressions. When you're adding and subtracting rational expressions, you can use what you know about adding and subtracting rational numbers. Remember, a rational number can be written as a over b, where b is not equal to 0. So for example, if I have two rational numbers, 4/5 and 3/7, and I want to add them, I remember I need to find a common denominator. My common denominator in this case is 5 times 7, or 35. That's my least common denominator. I can also have things like 70 would be a common denominator, but it makes the calculations a little bit trickier. So finding the least common denominator helps simplify the process. So 4/5 I'm going to multiply by a special one, 7 over 7. I'm not changing the value of 4/5, I'm just making it a different representation of 4/5. So multiply the numerator by 7 and the denominator by 7, and I will get 28/35. That's equivalent to 4/5. Same thing with 3/7. I multiply by a special one, 5 over 5, that's just 1, and this is a different form of 3/7. 3 times 5 is 15, 7 times 5 is 35. Now that I have this common denominator, I can add my numerators and put them over the common denominator. 28 plus 15 is 43 over my common denominator of 35. Now I'm going to do the same thing with rational expressions. So I have 9 over 10a plus 4a over 5b. Looking at the denominator, I can find a common denominator, the least common denominator. First, I'm going to look at my coefficients. I have a 10 here and a 5 here. I know 5 is a factor of 10. So when I just look at the coefficient and I'm looking at the least common denominator, I see it's going to be a 10. And in this first fraction I have an a, the second fraction I have a b. So I need to make sure in my common denominator I have all represented variables. So my least common denominator is 10, because it includes both the 5 and the 10, as factors, times a times b. And that way I can make sure I include all portions of each one of these denominators. So then I rewrite these fractions in a different form by multiplying by a 1. So for this one, 9 over 10a, I need a b in that denominator in order to make it be the least common denominator. So I have a b over b, which is just 1, plus, and here I need to include an a and a 2. So the 2 will get me to 10 here, and then the a will get me to my 10a times b, which is my least common denominator. So multiply by a 2a over a 2a. That's just a special one. It's not changing the value of this fraction. So then I go ahead and multiply through. I have 9b. On my denominator, I have 10a times b, or ab. I have the same here. That 2 times 5 is 10ab. That's just a different order. So I have something over 10ab, something else over 10ab, and I can combine them. So I have a 9b plus, I can multiply that 4 and the 2, that's 8a squared, and that's all over 10ab, my common denominator. Let's take a look at another example. So say I have 1 over 4a squared minus 4a plus 1 plus 1 minus a over 1 minus 2a. So in looking at that, I really would like to know the factors. If I can figure out the factors, then perhaps I can find a common factor and have a least common denominator including those factors. So I first factor the denominator of my first fraction, my first rational expression, and I have 2a minus 1 times 2a minus 1. I could also write that as 2a minus 1 squared. My second one is close to that. So I have a 2a minus 1 here and a 1 minus 2a. I notice that this is the additive inverse of this. I'm taking the negative of this one and the positive of this one. So if I factor out a negative 1, or a negative sign, I mean that negative really is just a negative 1, I'll have negative 1 plus 2a. Remember, distributing, I would get right back up to here. Now this one right here, I can rewrite that. I can put the 2a first and rewrite that as 2a minus 1, which I'm going to do down here. So this fraction stays the same. And then this, I just moved the negative from the denominator to the numerator. So I just multiplied by a negative 1 over negative 1, which makes a positive here and a negative here. My least common denominator, I can tell now by looking, I've got the 2a minus 1 in common. but I need two 2a minus 1s. And so I need to multiply this by another 2a minus 1 over 2a minus 1 in order to get my common denominator with this particular rational expression. So I have 1 over 2a minus 1 squared. I just rewrote that as squared. And I multiplied this by 2a minus 1 and the numerator by 2a minus 1. So my 2a minus 1 is right here, and I just squared the denominator. And I distributed the negative. So negative 1 plus a. And now I'm going to distribute and combine. So I have a 1 plus all of this after I distribute. So I have a negative 2a, and then I have a plus 1, and then I have a 2a squared, and then I have a minus a. So I can have both this and this all over my common denominator when I add them. When I add them together, I combine like terms, and I have 2a squared minus 3a plus 2 over 2a minus 1 squared. And 2a squared minus 3a plus 2 doesn't factor, and so I know that I am in the most simplified form. Okay, so let's look at another example. And this one you're factoring out. When you're factoring, you factor out the GCF, the greatest common factor. So I have 2 over a squared plus a minus a plus 1 over a. So that's equal to just factoring the denominator. That will help us find our factors that we need for our least common denominator. I have 2 over a times a plus 1. So just factoring out an a. And then I rewrote this as an addition problem just to make sure I didn't get my negative messed up. I often do that when I have a subtraction problem. So that's plus a negative of my numerator over a. So right now I can see I have an a here, but I need another factor of a plus 1. So I'm going to have to multiply this one by a plus 1 over a plus 1. So distributing my negative, I have my 2 over a times a plus 1 plus, I distributed my negative here, times a plus 1 over a plus 1. This is my special 1 right here. And then times a. Now I have a common denominator. I can rewrite this all over my common denominator, a times a plus 1. Now notice in here, a cannot be negative 1 or 0 because I can't have a 0 in the denominator. It's important to look at those constraints. So this works for a as long as a is not equal to negative 1 or 0. So then distributing, first I have the 2 from over here, and then plus negative a squared, negative a minus 1. And that's all over my common denominator. Combining like terms, I have a negative a squared minus a 2a, and this should be 2 plus a negative 1, which is just a plus 1, all over my common denominator, a times a plus 1. All right, let's look at another example where we're actually factoring over here. So I have x squared minus 3 over x squared plus 3x plus 2 minus x plus 1 over x plus 2. So my common denominator, my lowest common denominator, first I'm going to need to factor this and see if it has any factors in common. Hopefully it will, so I don't have to multiply this by two different binomials. So I have x squared minus 3. This factors to x plus 2, x plus 1. And then I'm rewriting this as add the opposite. So I have plus, and then distributing the negative, negative x minus 1. All over x plus 2. And now I have an x plus 2 factor here times an x plus 1. So I'm only missing x plus 1. So I'm going to multiply this one by x plus 1 over x plus 1. Okay, so when I do that, and x, my constraints here, x cannot be equal to negative 2, because that would make that 0, or negative 1. That would also make that 0. And we can't have a 0 in our denominator. Okay, so now we've got the same fraction. We didn't need to multiply this by anything. It already had everything needed in the common denominator. Plus, and then distributing negative x squared minus x minus 1, all over my common denominator. Now I can write this plus this all over that common denominator. So putting it all together, I have x squared minus 3 minus x squared minus 2x minus 1. And that's all over my common denominator, x plus 2, x minus 1, as long as x is not equal to negative 2 or negative 1. Combining like terms, I have a negative 2x minus 4 over x plus 2 times x minus 1. And that's equal to, I'm going to go ahead and factor out a negative 2. I think this might be something a little bit familiar down here, so I want to factor that out just to see. And factoring it out, I get an x plus 2. So negative 2 times x plus 2 all over x plus 2 times x plus 1. Well, right here, I have a very fancy 1, and that's a 1. And so I just multiply negative 2 times 1 to get negative 2, and my denominator is x plus 1. Remembering that x can't be equal to negative 2 or negative 1. Okay, the last example, it combines both of our addition of rational expressions as well as the division. So I'm going to take this a step at a time and do my numerator separate from my denominator before I even do that division. So I'm going to add those all together. So my least common denominator for this numerator right here, I need to have an x and a y. So it's going to be x times y. So when doing that, I can see that this one is missing an x, this is missing both an x and a y, and this one's missing a y. So I have 2x over y, and I'm going to multiply that by x over x, so I can get that common denominator. My 1, I'm going to multiply it by a special one, xy over xy, and my negative y over x, I'm going to multiply by y over y, which is a special 1. I'm going to do that same thing with my denominator. My denominator just happens to have, my denominator of the big fraction, just happens to have the same least common denominator in here, x times y. We need an x and a y. So here I have 2x over y times x over x to give me that common denominator, xy. Plus y over x, I need a y here in order to make my denominator be xy. Y over y. Minus 3. 3 is missing both the x and the y in the denominator, times x over y over x over y. Okay, so now multiplying out, I have 2x squared plus xy minus y squared. And that's over xy. Each one of those has the same denominator, just rewriting it with the x first. And that's over 2x squared plus y squared minus 3xy. And those each are under xy. That's what we were trying to do, is get that common denominator. Now we can combine them all over that same denominator, since we have the same common denominator. So my numerator is going to be 2x squared plus xy minus y squared over xy. And this sign just means divide. So it's divided by 2x squared minus 3xy. I rewrote this so this would be my center term, so it would look like a trinomial that was familiar and that maybe we can factor later, plus y squared. And that's all over xy. So I just rewrote this big, huge fraction right here as a division problem. Now that I have that division problem, I can rewrite that as a multiplication problem. So here's my division problem. I can rewrite it as a multiplication problem, just flipping that second fraction to multiply. And when I'm multiplying, I see that I have xy over xy. And that's just going to give me a 1. And so when I multiply through, I have this trinomial, 2x squared plus xy minus y squared, over this trinomial, 2x squared minus 3xy plus y squared. So I can factor both my numerator and my denominator, and I'm going to do that to see if I might be able to find some 1s and simplify it a little bit more. So factoring the numerator, I have 2x minus y, okay, times x plus y. I know that's going to be negative. Y times y gives me that negative y squared. And when I add the terms, the outsides, 2xy, inside negative xy, I get a positive xy. My denominator I can factor into 2x minus y times x minus y. I know it's going to be positive, but each one of those is going to be negative, because when I multiply that negative y times the negative y, I get a negative y squared. Now I have something in common here. I have a 1 I can take out. 2x minus y 2x minus y gives me a 1. 1 times x plus y is just x plus y over 1 times x minus y is just x minus y.